All right, guys, in this video, I'm going to give you a quick rundown of how to prepare for your Unit 2 project over looking at the relationship between two quantitative variables. There's a lot of stuff that you have to do for the project. It's all outlined in the rubric. I'm just going to kind of run through some of the big things that you're going to do with Google Sheets and or your calculator. So all that's going to be explained in this video. So I went and actually collected some data off the internet, and it dealt with children. So I had 15 children, and it dealt with the height and how height of a child is related to the dead space. Now I want to actually show you what this is. This is the pulmonary anatomic dead space. Okay, now I don't really know a whole lot about this, but I'm assuming if I'm in the medical field, this is probably something pretty important. It is the total volume of the conducting airways from the nose or mouth down to the level of the terminal bronchioles, and is about 150 milliliters on the average in humans. This fills with inspired air at the end of each inspiration, but this air is exhaled unchanged. So, listen, I'm not a doctor. I don't know a whole lot about this, but it sounds like when you breathe air in, this is the part that does not get changed inside of your lungs. So this is the dead space, air that is brought into your lungs, but nothing is done with, right? If you have a lot or a little, I don't know if that's good or bad, but that's just the data I looked at. So again, the point I'm trying to make is I don't know a whole lot about what this is, but I thought this was something kind of interesting I found on the internet about the relationship of height of a child versus how much pulmonary anatomical dead space they have measured in milliliters. So again, the whole point is whether you know a whole lot about the topic or you know little about the topic, you could still complete this project. So the minimum requirement was at least 15 data points. So I do have 15 data points. And the first step is just making a table. So here's my table right here. Basically, the height is the explanatory variable, and the dead space in milliliters is the response variable. So I would have to write all that out and explain all that, which is pretty easy to do. In fact, I actually have a little written explanation down here, but I'm going to show you that in 1 second. And that would obviously need to be included on your project, on your poster board. All right, so the first thing that you're going to be tasked to do is to take this information and make it a scatter plot. Now, I didn't really need the child numbers. That was just showing that these information came from 15 different children. You obviously don't need that. But if I'm going to make a scatter plot, I'm going to grab my data, and I'm going to include the headers there. Insert chart. And sometimes it takes a minute, and literally it should know what to do right away, right? And if for some reason it doesn't, make sure you go ahead and grab scatter plot. All right, and the first thing that should come up is a scatter plot. If it doesn't, under chart editor here, under chart type, just hit the arrow and make sure you select the one that says scatter plot, but it should automatically do that for you. Now, if you like the way it looks, you shouldn't really have to do a lot of fidgeting with this. If you selected the headers, you should definitely have the variables listed here. Now, just make sure that the X column is first, the explanatory is first, because it will flip-flop them if you don't have them in the proper order. All right. So the next thing you're going to be tasked with is simply kind of explaining what you see in the scatter plot, and that can be done in a couple sentences. So I see a fairly linear, pretty strong, positive relationship, and it does show that there's a tendency as the height of a child increases, the pulmonary anatomical dead space in milliliters of that child also increases. And just avoid the word cause there. So there's the first kind of big task, is making a scatter plot of this. All right, the next task that you have to do is to create the linear regression model. It's actually find the linear regression model. And you're actually going to do this two ways. The first way you're going to do it is by using the formulas. Now remember, the formulas are going to require the mean of the explanatory and the standard deviation of the explanatory variable, and the mean and standard deviation of the response variable. So I'm actually going to let Google Sheets do that for me. So notice I set up a little chart here, and underneath all of the heights, I created a row for mean, standard deviation. So I'm going to go and find those values as well. So to do this, all you got to do is select the box. You could use any box you want. I just thought it would make more sense to put it right underneath here in a little chart. And then the other nice thing is you could print this out when you're all done, and you could have it all on your poster board. All right, so I'm going to hit Insert, Function, and I'm going to go under Statistical, and I'm going to find Average. Now, they don't have mean. They call it average, but we all know what average is. And then all you have to do now is select the data alone. Don't select any words. And hit enter, and you'll have your mean. I'm going to do the same thing here for the response variable. Insert, function, statistical, average. Make sure you select the right one. highlight all the data, hit enter, boom, you got your mean. All right. Then for standard deviation, select the box, insert, function, statistical. Now you got to go all the way down to the S's for standard deviation. And there's a lot that look like it, so just be very careful. You want this one, STDEV. There's a couple other ones that look just like they would abbreviate for standard deviation, but be very careful you choose the one that's just standard deviation. When you select it, it actually says standard deviation underneath it. And then once again, highlight all of the data, hit enter. And I'm going to do the exact same thing. I'm going to go to insert, function, statistical, scroll to standard deviation, select all the data there, and boom, there it is for the response variables. All right, so now the other thing I need is the correlation. So I'm going to do ahead correlation here. So again, insert, function, statistical. I'm going to go to C's for correlation here. And let's see if we could find it right here, CORREL. Now they call it the Pearson product moment correlation coefficient. That's the correlation coefficient. We don't need that big special name there, but correlation. Now here you got to be careful. You got to select all the X's first. Don't hit enter, hit comma, then select all of the Y's, and then you could go hit enter. All right, and then what I like to do here actually is, because remember correlation is not for X and not for Y, it's actually for both of them. So I'm going to go ahead here and select both boxes that are highlighted there, and I'm going to go ahead and hit format, and I'm going to merge those two cells together so it's one thing. Now I just noticed for some reason my scatter plot added in some points there, so I'm actually going to redo the scatter plot. I don't know why it's doing that. So I'm going to delete that and I'll redo that in a moment. All right, so again, for whatever reason, I'm going to go ahead and make that scatter plot nice. I'm only going to select, what happened is I think I accidentally selected one of these other rows and it made the means a point or something like that. So insert, chart, and there's my scatter plot. So again, I don't know if I just made a small mistake there. All right, so now that I have all these values, I could actually go ahead and by hand, you have to do this on your poster board, find the slope and the y-intercept. And I'm not going to show you how to do that right now. You could do that on your own. Now, the other thing is you don't need all these decimals. So one thing you could do is you could actually highlight these boxes. And then up here in the kind of the toolbar, you could see that you could reduce the decimal sizes. So you could reduce it all the way to whole numbers, which I would not do. I would at least go 3 or 4 decimals. So you know me, I like 4 decimals, so I have 4 decimals here. All right, so the correlation is 0.8463. That confirms that it's a positive, linear, fairly strong relationship, which we already said earlier. And now I can actually use the formulas. Remember, the formula for slope is R, 0.8463, times the standard deviation for Y, which is 23.6476, divided by the standard deviation for X, 19.3679, and you can get your slope. And then the A value, the y-intercept, is going to be the average response variable, the average y, 66.9333, minus the slope that you just found, so you do have to find slope first, times the average x of 144.6000. And again, those formulas are on the board in my classroom or on the wall, and they're also should be in your notes for sure. All right, so that is one way that you're going to find the formula, okay? And the second way you could do it is using your calculator. So I'm going to show you how to do that real quick. And you do have to do this. Now, before I calculate this, keep in mind that the calculator might be a little bit off from what you did because it doesn't round at all. All right, so you obviously have to enter this data into your calculator. So stat, edit, in list 1, I put all of the heights. In list 2, I put all of the dead space values. And that was already in there for me to save some time in this video, but you can see it all there. Now, in case you want to check the mean and standard deviation, you could always do that by doing this. Stat, slide over to calculate, go to 2 variable stats, because we have 2 variables. Make sure that the x is L1 and the y is L2. That's where I put my data in. And go ahead and hit calculate. And this is another way to get the average for the x, that's x bar, the standard deviation, that is s. So all those numbers are exactly what we found. And then you could scroll down for the average y, 66.93. The standard deviation is s, 23.64. And it's all there, pretty cool. And you don't need any of those other numbers, but it's all there for you. All right, now, to get the calculator to find the regression equation for you and to get to find correlation, we have to just do one thing real quick. So go under mode and go all the way down the bottom. Just make sure StatWizards is turned on, and the other thing you have to check for is make sure Stat Diagnostics is turned on. If stack diagnostics is turned off, it will not give you correlation. So please make sure that is done for you. Okay, so now you're just going to hit stat, slide over to calculate, go all the way down. Don't choose number 4. It says ax plus b. Remember, the formula that we love is a plus bx. It's number 8. So linear regression, a plus bx. Make sure L1 is your x list, L2 is your y list. Leave everything else blank and hit calculate here. And this will tell you that the slope is negative 82.48. Negative 82.48. And again, I like to keep 4 decimals, so 0.52 or 4852. The y-intercept is, whoa, I said that completely wrong. I'm so sorry. The y-intercept is negative 82.4852. The slope is 1.0333. And again, notice the correlation there is 0.8463, which we already knew from Google Sheets. And it also gives you correlation squared, which you could have just done that on your own. Come on, correlation just 0.8463 square it, but the calculator does it for you, 0.7162. Okay, now remember when you do it by hand, you might not get those exact same numbers to 4 decimals, but it should be pretty darn close. All right, so that is all stuff that you have to do for the project. All right, the next big thing you have to do for your poster board is to interpret these values. So please make sure you understand how to interpret them. I'm going to go through it real quick. I'm not going to type it or write it down. I'm just going to say it out loud, but it's all in your notes. So let's start with the slope. The slope tells me that for every 1 more centimeter that a child grows, his or her predicted pulmonary anatomical dead space will increase by 1.03 milliliters. So make sure you have that word predicted in there, and then it sounds like it's something continual, right? It's as the x variable, as the height goes up by 1 centimeter, it is predicted that the dead space goes up by 1.033 milliliters. And then the y-intercept tells me that if a child has a height of 0 centimeters, we would predict their anatomical pulmonary dead space to be negative 82.49 milliliters. Obviously, that makes no sense. A child cannot be 0 centimeters high, nor could you have negative amount of dead space. So that doesn't even make sense. And as we talked about in our notes, sometimes the y-intercept does not make sense. It doesn't mean it's wrong. It just doesn't mean it makes sense, probably because of extrapolation. Look, all of my data came from about 110 to 180 or so. So obviously making a prediction for a child that's 0 centimeters tall would be extrapolation and not reliable. Doesn't mean it's wrong, though. It just means it is what it is. All right, now next up, what you have to do is you have to do a residual plot. So let me show you how to do this in Google Sheets. All right, so what we have to do is we have to find all of our residuals. So remember, a residual is the actual y minus the predicted y. That's the actual dead space minus the predicted dead space. So in my chart here, I have a column for predicted dead space. So how do you find the predicted dead space? That's with your equation. I'm going to use the one from the calculator. You could use the one you found by hand. Either one should be fairly close, but again, the calculator is going to be a little bit more accurate because it doesn't round. So in this box, I'm going to type equals. Equals means I'm going to put an equation in here. All right, and I'm going to type in the equation. It was negative 82.4852 plus 1.0333 times, and I'm going to go ahead and actually select the 110. Remember, it's the x value, right? The regression equation takes the x to predict the y. So it's going to take the height to predict the dead space. So I'm going to select the 110 there. Now you're going to see, now I could have typed 110, but you're going to see why this is beneficial in a second. So when you hit enter, boom, there it is. There is the predicted dead space from the model, 31.1788. And when you select it, you can actually see it up here in the function line, but you have to have an equal sign first for it to see that. Okay. Now the cool thing about Google Sheets is if I want to repeat all of that for the remaining rows, all I got to do is highlight that spot, and then this little tiny blue square, I'm going to cross over and you'll see a little cross comes there. Select that cross and drag down, and it'll automatically fill all those in. So for example, if I select this one right here for child number 12, and we look up here, it took the same equation, the a value of negative 82.4852, plus the slope of 1.0333, and this time it took B13, which was the height for that child, 159. So it's cool. It's a quick, easy way to do that. All right, so now I'm going to come over to my residual column, because remember, a residual equals the actual dead space for that child. And I'm not going to type in 44. I'm actually just going to select that cell, minus the predicted dead space. So I'm going to select that cell and I'm going to hit enter. Now the reason why I did this is because now I could just select that cell, grab that little blue square and pull down, and it'll automatically calculate all my residuals for me. So all the residuals are automatically there, which is super, super awesome. All right, so that's a nice quick way. And again, you need all of this for your project to be present on that poster board. So this is kind of a nice little setup that I have here that I highly recommend you copying. All right, so now I want to make my residual plot. So now I got to be a little careful here. All right, I need to select the X values, and then I'm going to come over to the residuals. And to do this, if I just select the residuals, then it's going to select off of the heights. Or if I try to grab and drag, it's going to select all of them. So the way you do this is you select the heights first, then hold the control button down and select the residuals. That's how you could select two different sets of data with space in between. So again, select the heights, then hit the control button on your keyboard, and while you're holding the control button down, select the residuals. That way you get both of those. Go Insert Chart. And now notice it made a column chart. I don't want that. So under chart type here, I'm going to select chart type and I'm going to find scatter. I had to scroll down a little bit for it, but there is a scatter plot here. And now I have a nice scatter plot of my residuals. All right, now remember, if you want to edit this, you're going to select those little three dots and go to Edit Chart. And under Customize, like one thing I noticed is there's no axes titles. So I could go under Customize and go Chart and Axes Titles. I could select the chart title and I could type in Residuals. Residual. I can't type. Residual Plot. And then I could go and select the horizontal. And I'm going to select height in centimeters. Boy, I'm having a tough time typing today. And then I'm going to select the vertical axis. This would be the actual residual values. And that just allows me to name all this. So there's a nice residual plot. And by the way, I think I like this residual plot. This is a beautiful residual plot. It shows nothing. That means that my line was perfect. Remember, how do you know that your linear model is an appropriate linear model? Well, A, the scatter plot looks pretty straight. B, the residual plot shows no pattern, which means that my linear regression model is accurately going through my data. So this is all things that you're going to need to describe in your projects. This is awesome. All right. So that covers the bulk of everything that you need to do. Obviously, in the rest of your project, you could copy all this, print all this, paste it on there, explain everything you have to do. The only other thing you will need to do is get R-squared. So again, if you go back to your calculator, remember it does tell you what R-squared is. But to get R-squared, remember which is called the coefficient of determination, just R-squared. Another way you could get R-squared is to just go equals and then just type in 0.8463 raised to the second power. And boom, you could get it that way as well. I mean, it's pretty easy. Or you could just square it on your own on your calculator and type it in. It doesn't really matter. Remember, R-squared tells me that about 72% of the variation in dead space is actually because of the variation height. That's a pretty strong, reliable connection. Not very, very, very strong, but it does show that a large percentage of the dead space in a child is because of their height. I mean, come on, if you're taller, you're going to have more room for that dead space. The other thing you are going to need is S. Remember, S is the standard deviation of your residuals. So to get that, you're literally just going to hit Insert. So I made like a little row here that just says S. I'm going to go Insert, Function, Statistics, and we could go ahead back to standard deviation. And remember, we're getting into just the STDEV. Don't use any of those other ones by mistake. So the standard deviation, and then I'm going to go ahead and select the residuals. So the standard deviation of the residuals is 12.5967. So that tells me that when I do use my line to make predictions, I'm typically going to be off by about 12.6 millimeters, which, I don't really know a whole lot about dead space. I don't know if that's a lot or a little. Kind of looking at the numbers, where the numbers are ranging from about 44 millimeters to 101, 112 millimeters. making a prediction and you're off by almost 13 milliliters, that actually kind of sounds like a lot. So, the lower R squared, it's not very, very strong. It's okay, but it's not great. It's not 99% or anything like that. Combined with the kind of a high S value, for me, it means that my data is not necessarily the most reliable. But again, please make sure you understand that my model is very appropriate. It definitely is appropriate. It goes through the data. The residual plot is nice and scattered. So it's definitely appropriate, but how reliable is it? Well, not great. And that's because this isn't the strongest connection between these two things. So obviously there's other factors that contribute to the dead space of a child as opposed to just their height. But these are all things that you're going to talk about in your project, and I hope that as you've been learning, all makes sense to you. So hopefully you followed through how to do all of that stuff. Those are all of the big things that you're going to need to do. Remember, all you got to do is copy and paste this to your poster board. Keep in mind that any of the math work, like actually showing the math work for finding your slope and y-intercept, that does need to be done by hand, or you could computer generate that and paste it on as well. But like all this other stuff I just did, like everything I just did in Google Sheets right here, you don't have to show any math work for that. You're just going to let Google Sheets kind of make that easy for you, right? And that's kind of the cool thing for this chart. And you could jazz this up, make it different colors, and you could make your residual plot red instead of blue. I mean, whatever you want to do to make it cool for you. But, you guys are going to be tasked with doing all the interpretation kind of stuff, but hopefully this video made it pretty simple for how to do all of the actual finding of these values for you. And it's pretty simple. I don't think it's overly difficult. And if you need to pause the video at any point, replay it to see what I did. And don't be afraid to email me or ask me if you need help as well. Hopefully this video explains all the kind of tricky stuff. That way you could get a really nice grade on this project. All right, see you later. Enjoy.